What is up, YouTube? I'm back today with another R tutorial. It's been a couple of months since my last one, but my season for my basketball team is over now, and school is winding down. So, hoping to get some more out more on more of a consistent basis. But today, I'm back with one of the coolest ones I think yet. We're going to be using StatsBomb's Open R package again, like we did with, I believe, the past maps. We did the Liverpool Tottenham Champions League final. So today I'm going to throw it back to what better than the first Champions League win for my club Chelsea, and kind of show you how to create shot maps based on the data from that game. Thanks to StatsBomb and their open data, which is a huge help to anyone looking into not just soccer analysis, but getting better with R and all the inner workings of it. So this is the final product that we're going to be making on the screen. I'm just going to show you how to make the Chelsea one. It only takes one line of code to switch them, so it's not too hard. But yeah, let's get into it. So we will switch over to R. There we go. Yeah, so what we'll do first is, this is very similar to the setup of the pass map code. I'm going to run all the library, load in all the libraries. It shouldn't take too long. My Wi-Fi isn't great, so it's probably gonna take a little bit longer than normal. But first thing we're gonna do is, so the StatsBomb has their library, which has a bunch of functions in it. Kind of go over what we did with the pass map tutorial. The first thing we're going to do is use the free competitions function. So I'll run that and show. All right, it's not what should happen. There we go. So if you run that, this is what it shows you. So basically, it shows all of the competitions that they have in their free data package. So we have the Champions League, the male Champions League data for all of these years. We're going to be using the 2011, 2012, but if we go back, or I'll just put it into the data set so we can look at it better. Sorry, yeah, here we go. So basically, they have Champions League data on the finals from the past 10 years or more. You can go in and do the Women's Super League for England for the past 3 years. And then obviously they have Messi data from all different types of years, pretty much his whole career with Barcelona. So yeah, it starts here: Spain, La Liga, male, 2019, 2020, all the way down. So you can go in and look at all of Messi's data, even chart his whole season. But today I'm just going to do one game. So what we'll do is filter this data set of competitions for competition name, Champions League. We're going to be looking at the final and then the season. So it is in full year / full second year format. So you just filter for two things, and then we're going to send that back into our competition object. I'll show you what that looks like. So competition. So yeah, the Champions League has a bunch of different variables describing that year of data. And then we'll move on to their free matches function, which then, so once you have created this competition object that holds what in our case is the Champions League, this function will pull all of the matches that they have from that competition from that year. And we will put that into competition data. There we go. So there we go. It only has one match from this year, which was May 19th, 2012. I remember that forever. But so we're going to use just this match, which is perfect. And then once you have that, so I'll say this, you might have to go play with it a little bit, but if you were to do like a competition with several matches and you only wanted to do one match, this competition data set will be filled with matches all the way down, and it'll each have a match ID. So if you were to have several matches, you would want to filter this competition data set for the specific match ID and then overwrite it back into competition data. But we won't be doing that. We won't have to because there's only one match in the data set. So now that we have the data for that specific game, we'll use their next function of StatsBomb free events, which is their own built-in function where if you have, like we do, the competition data set of just one single row of a match, it will scrape that, run through that match in their own data frame and scrape each, the whole event data for that match. So it'll scrape a row for each event that happens in that game. And we will overwrite, or not overwrite, we will send that back into single match data frame that we will build off of as we want to analyze each shot from this game. So there we go. There we go. Single match has just under 5,000 rows. So this is the event data for this whole game, every single event that happened in the Champions League final. But first, what we want to do is they have another function. So when the data initially scrapes from their, I'm not sure if it's an API, but wherever they hold their data, some of the data gets nested into single columns. So for example, you might have XY locations nested into one column. Basically what you want to do is take the data frame that we just created and put it into the function all clean, which StatsBomb, it's their own personal function that will clean a event data and make it more usable. So we'll run that quickly as it joins a bunch of columns. There we go. I think it worked. Yep. So you can go through and look at the decipher which ones changed and which didn't by yourself, just to get a better feel for what that function does. But now that we have all the match data for that game, since we're analyzing shots, we want to filter the data set. So what I usually do is find that column for each game that this what's the word, explains what type of match event is that row symbolizing. So in our data set, the column type name describes each event. So I will run the unique function. So we'll get each specific type of action in the game. So starting 11 rows, half start, the rows in each data frame that signify the half starting, each pass, ball receive. Basically, this is showing every type of action that's in the data set. So this just helps us confirm what we want to look for in shots. So, could some other data providers label theirs differently. So we want to know what StatsBomb calls theirs, which is shot. So now all we have to do is filter. So we have single match data. This has both team shots. So basically you just scroll over, find team name. That's how we want to filter. So we'll filter for this data set, filter for team name equals Chelsea, type name equals shot. Now we'll put that into a new data frame called single team. There we go, 14 shots throughout the game. They didn't have a ton. I think we'll all remember that. And then one kind of funky thing that I'm glad it shows this. So the match went to extra time and their periods labeled 1 for the first half, 2 for the second half, 3 for the first half of extra time. They didn't have a shot in the second half of extra time, so there's no 4. But then 5 signifies penalty shootout. So I'll do this at the end, but I'll basically get into that. So once I have this single team data frame, what I tend to do is filter it for just the columns that we'll be looking at, and then overriding that into a new data set. Basically, you don't have to do this because the columns don't change, but I tend to do this because it's easier to, once you're looking at a new data set, it's easier to filter through with your eyes through like maybe 20 columns instead of 150, or is it 153? So that's usually what I do. If if I'm not in a rush. So we'll create that. Single team shots. There we go. 14 rows, 16 columns. So we have player name, X and Y location, the expected goal value of that shot, the technique of that shot, the body part that each shot was used with, the type of the type name of the shot, the outcome of the shot, and shot end location, which we won't use, but I put in there just in case someone was looking to. And then we're only doing one mutation in this tutorial. So what we want to do now with this data frame is find out which of the shots were goals. So we have a shot outcome name, but we want to create a column that where if this row that signifies a shot was a goal, we want to make it true. If not, it's false. That way we can create a legend on our plot that will eventually color. So green will be a goal, transparent or dark gray will be no goal. So what we do is pipe this data frame. So now we're saying anything after this, we want to change this data frame. So mutate, which is create another column. We're going to call it goal. And then the case when function is really good. I love it. I use it a lot. Basically, you can create a column based on a value in a different column. So the first row of this basically is for this column, when the shot outcome name column equals goal. So I'll show you that. So when this column equals goal, we're going to create a column here that will be true. And then when the shot outcome name does not equal goal, it will be false. And then I'm going to override that into the same data frame. So it's in the way. There we go. So you can see at the end how the shot outcome name for the first row was not goal, so it's false. Here we go. This is Drogba's goal. So this equaled goal and it's true. So you also see the penalties that went in are true. So we don't, that's the last step that I mentioned earlier. We don't want these extra time penalties. So we will filter the final data frame. This means not equal to. So when the period does not equal 5, so 1 through 4, we will filter this data frame for that. So basically saying we want all shots in all periods except for the 5th period or extra time. Overwrite that back into the same data set, and that leaves us with 9 shots. So from here, we have the final data set, and we will go to the plotting aspect of it. So for the first line, we're going to create our pitch. There we go, dark gray. And then from there, we want to create our points. So we use our team shots data frame. And here we go, the mapping part of it. X is equal to our X locations. Y is equal to our Y locations. We're going to fill it by the goal column. So if it's true, it's going to be green. If it's false, it's going to be gray. And then we're going to size it by the expected goal so we can get a look at which shots that either went in or what didn't go in had the best chance of, based on stats, bombs model going in. And then anything after this will affect the points. So basically we're going to color them dark gray. And then this is the shape of it, which will be circles. So let's see what that looks like initially. I must have changed that. Here we go. There we go. So you'll see this is on the wrong side. I'll fix that after there, but basically you can see the goal is true. False is colored by that and sized by expected goals. But so for each match, obviously expected goals is going to change. So the next thing I believe we do is, we're going to make the limits from 0 to 1. So expected goals range from 0 to 1. And then we're going to do our breaks. So the label will have 4 breaks in it. It'll have 0.25, 0.5, 0.75, 0.1, or 1. So this creates a consistent label and will create a consistent size. So It won't differentiate for teams that create or don't create the same amount of chances. There we go. So now they're normal compared to the size of the shot. So from there, so this green and red color scale is what R does automatically without you telling it what to do. So we're going to use the scale fill manual, which refers back to the fill part of the AES. So you want to look into so our fill is equal to our goal column. So we're going to want to look back at what our goal column values are. So we have true and false with capital letters. So we want to make sure those are correct in the scale fill manual function. So our breaks are equal to true and false. Values responds to the colors of that. So the first one responds to true. We're going to make those green, and then gray 15, which is the same as the background. So we're going to make it dark gray for the non-goal shots. And then this refers to the legend. So you can change it from true to false. We're going to make it goal, no goal. There we go. So it changes here, goal, no goal, and then makes the points transparent if they are not a goal. So next thing we're going to do is just scale, make sure that X and Y axes are scaled correctly. StatsBomb's data is collected on a 0 to 120 scale for their X locations and 0 to 80 for their Y. So we just want to ensure that those are correctly scaled. Shouldn't change much. There we go. The next, we're just going to hit on all the theme aspects that I usually do. So you got your plot background, plot title, plot subtitle, plot caption, the position of the legend, and then you can, I guess, read through all of those. I don't want to spend too much time on it just because you can change it to however you want. You know, this is a template that I created that I think is sharp and can probably be tinkered with a bit, but I think it's pretty good. So let's see how that affects what we have so far. There we go. So we have goal, shots, stats, bomb, expected goal. It's still horizontal, so we'll get to that, but it looks a lot cleaner already. And keep in mind that these shots are also on the wrong side, so it should be flipped, but I'll show you what we do with that. So we're going to change the title of the plot. We have the title, the subtitle, and then also in the labs function, you can directly refer to the legends title. So our legend for the fill is currently goal, but we want to make that outcome of the shot, and then the size legend right here. So there's different sizes. It refers to the size of shots, and we're going to make that just expected goal. So should just change that part of the plot. There we go. Already getting a lot cleaner. So all we have to do now is flip the plot vertically, and that will also flip the shots as well. So we'll use the coordinate chord flip function. So we want to take only the right side. Like I said, the x-axis is 0 to 120. So we only want halfway, 60 to 120. So we want the right side of the pitch, which is the X limit here. And then the Y limit is 0 to 1 or 0 to 80. So 0 on the bottom left to 80. So we want to take obviously the whole width of the pitch once it's flipped vertically. So let's see what that looks like. There we go. So it looks a lot better now, and it's funny that we don't need to flip the y-axis because that does it naturally through this function. So as you can see, I mean, I'll always remember, I hope you guys do, but Drogba's goal off Juan Mata's corner was on the right side of the 6-yard box. So that's how I'm making sure that they're aligned correct. So this is our final product. I'm going to change one more thing, add one thing. So I tend to like to have the outcome first. So this guides function, we can do the fill so that we're filling the color. We can use that to order it as the first legend. And then I'm going to put all this back into the objects labeled P1 for plot one, or you can use whatever, but um, that will be our almost final product. We're going to do this so we can create the whole plot as an object and then add an image on top. So I will plot only the shot map. There we go. Now the outcome is on top of the expected goals. So just to add a little touch at the end, we're going to use the draw image function to add the logo of Chelsea. I usually so I look up Chelsea, Wikipedia, PNG. You can do any team. So Bayern is the other team this match. Usually the first one that pops up. Because I believe, to my knowledge, Wikipedia images or club logos are, you're allowed to use them freely as long as you're not profiting or whatever off of it. So what I do is left click or control click on a Mac. You want to copy the image address to keyboard, and then this will be the same thing, but I'll show you what I do. So I, highlight all of it except for the parentheses and then paste it in there. So it'll directly refer to that image address. This is the X and Y location, so I'll put it in the top left corner. You can put it in the right, whatever. And then width and height of the image. If it's a equal sided image, you want to keep the numbers equal just so it doesn't get distorted. So this is the final product here. So I'm going to run that all together. It'll draw that picture from the image. There you go. Top left. And then lastly, all you need to do is GG save the plot. So I called it Chelsea Shotmap tutorial. I usually do the height 5, width 8, so it's more of a horizontal type of setup. And then this is your pixels. So I believe that's the clearest the retina you can get for R. So we want to save that. And then we'll go to where it's saved. Might take a bit. Oh, it's probably no. And there's our final outcome. So I think it's a really good shot map. Obviously, you can add some people create a little bit different. There's always, you can add your own touch to it. So as always, you can play with the theme, play with the colors, but I really wanted to get a template out there for everyone to kind of have to be able to use. So continue to mess around with the stats bomb data. It's truly one of the best resources out there. And thanks to everyone at Stats Bomb. Obviously, I'll tag them in this, and if they see it, I don't know. But so this is going to wrap up this tutorial. As always, it's super exciting for me to keep getting these out there, and love seeing these used to create plots all around the world. So it's really cool from my end. So as always, hopefully this was helpful enough and clearly stated, but my DMs are always open if you need help with your own making of the plots, and would love to help anyone out with theirs. So yeah, with all that said, thank you for tuning in for another one, and I'm looking forward to getting another one out soon, which I think the next one hopefully will be very similar shot map, but we're going to do hex charts that are filled by a specific variable, so some heat map stuff. That's the plan if I can get that going, but we'll see. So but thanks again, and see everyone next time.